Atmospheric science. Some useful definitions. Atmospheric science is the study of the atmospheric envelope, the composition, the structure, chemical and physical interactions of the elements of the atmosphere with living organisms on the Earth. Meteorology is the study of the physical processes occurring and their explanation in the atmosphere. Climatology is the physical state of the atmosphere in long period of time, more than a week. Weather, the physical state of the atmosphere in a short period of time, less than a week. Atmospheric composition. The table below, this is the 11 most abundant gases found in the Earth's lower atmosphere by volume percentage. On the gases listed, nitrogen, oxygen, water vapor, carbon dioxide, methane, nitrous oxide, and ozone are extremely important to the health of the Earth's biosphere. The table, average composition of the atmosphere up to an altitude of 25 kilometer volume percentage. It can be seen that how the volume percentage of the components of the atmospheric layer varies and which are the most important in the Earth's atmosphere. Atmospheric layers. The Earth's atmosphere has been divided into several different layers that can be defined according to air temperature. The graph below displays these layers in an average atmosphere. Vertical change in average global atmospheric temperature. Variations in the way temperature changes with height indicate the atmosphere is composed of a number of different layers labeled above. These variations are due to change in the chemical and physical characteristics of the smell with altitude. In the graph, it can be seen that how this graph shows how the temperature varies in the atmospheric envelope with altitude in a zigzag way. According to variation of temperature with altitude, the atmosphere has been divided into 4 different layers as follows. The first layer is called the troposphere. The depth of this layer varies from about 8 to 16 kilometers. Greatest depths occur at the tropics where warm temperature causes vertical expansion of the lower atmosphere. From the tropics to the Earth's polar regions, the tropopause becomes gradually thinner. The depth of this layer at the poles is roughly half as thick when compared to the tropics. Average depth of the troposphere is approximately 11 kilometers as displayed in the figure below. Most of our planet weather occurs in the troposphere. This image shows a view of this layer from an airplane window. Above the troposphere is the stratosphere. This layer extends from an average altitude of 11 to 50 kilometers above the Earth's surface. The stratosphere contains about 19.9% of the total mass found in the atmosphere. Very little weather occurs in the stratosphere. Occasionally, the top portion of the thunderstorms reach this layer. The lower portion of the stratosphere is also influenced by the polar jet stream and subtropical jet stream. In the first 9 kilometers of the stratosphere, temperature remains constant with height. A zone with constant temperature in the atmosphere is called an isothermal layer. From altitude of 20 to 50 kilometers, temperature increases with the increase of altitude. The higher temperature found in this region of the stratosphere occurs because of localized concentration of ozone gas molecules, O3. These molecules absorb ultraviolet sunlight, creating heat energy that warms the stratosphere. Ozone is primarily found in the atmosphere at varying concentrations between the altitudes of 10 to 50 kilometers. This layer of ozone is also called the ozone layer. The ozone layer is important to organisms at the Earth's surface as it protects them from the harmful effects of the sun's ultraviolet radiation. Without the ozone layer, life could not exist on the Earth's surface. Separating the mesosphere from the stratosphere is a transition called the stratosphere. In the mesosphere reaches its coldest temperature, about -90 degrees Celsius, at a height of approximately 80 kilometers. At the top of the mesosphere is another transition zone, known as the mesopoles. The last atmospheric layer has an altitude greater than 80 kilometers and is called the thermosphere. Temperatures in this layer can be greater than 1,200 degrees Celsius. These high temperatures are generated from the absorption of intense solar radiation by oxygen molecules, O2. While these temperatures seem extreme, the amount of heat energy involved is very small. The air in the thermosphere is extremely thin, with individual gas molecules being separated from each other by large distances. Thank you very much for listening.